In this tutorial, we're going to go through the basic components of a 3D model. Now, you might think that that's a little obvious because when you load a 3D model, you might think you can see all of its components. You can see its polygons, you can see its vertices, and you can see the edges that connect those vertices. But 3D models have a number of different components that are hidden from view. So one of the things that you might find, depending on the package that you're in, when you zoom in to a model, for example, the polygons actually disappear. So from here you can see the polygons and from here you can't. And that tells you something very important. The polygons are directional. They face in a particular way. And that means that there has to be something that's telling the system what way to face. And that's done by a thing called a normal. So I'm going to come down here and reveal the normals. Now, of course, depending on what 3D package you're using, revealing the normals will be a different process, and that's not really that important. What is important is that now when you look at this model, you can see blue lines pointing out from the very middle of the polygons. And that normal tells the system what direction this polygon faces. So if I select all of the faces and I come to my mesh and I choose flip the normals, now suddenly I can see inside the box, but I can't see the outer edges. And you can see that as I rotate the camera, I can only see the interior faces of the box. And that's because the normals are flipped. And again, if I select all of the faces and go back to my mesh and flip the normals once more, we can now see the box from the outside and not from the inside. And so this is a really important functional component of a 3D model, because this tells the system what direction the polygons face, but also it tells it how to be lit. So now I've gone ahead and I've created a sphere, and you can see I'm still displaying the normals. And what you can see from this is that the normal is helping the system define the lighting. When a normal points towards a light source, the polygon is lit. And as the normal points further and further away from it, the polygon is less and less lit until once it's pointing completely away, it's completely unlit. And so normals are a way for the computer to actually work out how to light the model that you're working on. Now, what you would have seen from the box example is that the normals are movable. And in this case, I have rotated the normals a bit, and you can see that it has dramatically affected the lighting that is actually happening on the sphere. It's exactly the same sphere as the previous one, but I've moved the normals and now the lighting appears wrong. Now, obviously, this is an artificial example, but when you work with complex models, this is something that you may encounter quite often. Here is a 3D model that I have downloaded off the internet, and you can see the person that has modeled this has done an excellent job. But as I rotate it and move in towards the cockpit, you can see that there are some light discontinuities, and this has been caused by issues with the normals. And while this is not to teach you how to fix the problem, this will give you a start point with which to troubleshoot them. Now, another hidden component of a 3D model is a thing called a UV map. And a UV map exists to solve a simple but complex question. How do you take a 2D picture and place it accurately on a 3D object? So here you can see I've got a bunch of numbers, and I want each number to be placed at a very specific point on each one of these faces. And I want to be able to control and choose where those numbers go. The UV map is the way of controlling where these 2D coordinates are placed into 3D space. So if I select this model, you can see my UV map. And effectively what I've done is I've cut open this box and I've laid it flat. So now when I look at the textured version of this object, you can see that each one of these faces that has been laid flat helps me determine where the image is placed in 3D. And these are movable. So now if I select this face, for example, and I move it around, you can see that it's changing where each one of these numbers is appearing. Now once again, this is not a tutorial to teach you how to UV map, only to tell you that it exists and it's very, very important for placing your textures onto your 3D object. The final component of a 3D mesh that we're going to look at in this tutorial is there to solve yet another simple but complex question. What should this 3D object actually look like? How do I define this box and make it look different to this box? On the right here, you can see in Blender a whole bunch of properties. And as I select each object, you'll see that these properties change from object to object. This is something called a shader. So in any 3D package that you use, the look of the 3D object is defined by something called a shader. If I switch to the rendered view in Blender, you can see that despite being defined by the very same mesh, each one of these objects now looks incredibly different. And so just by using a shader, we are able to define a very, very different look from exactly the same mesh.